Okay, so all these problems are about the same picture. And remember, it's super important when you start and they give you a picture to look to see what the picture counts and then look to see what the functions are describing. So they want us to talk about an accumulation function. Okay, so let's see. So let's look at the first one. So a lot of times they just change up the words. So this is the IROC, and then we learn that's the derivative. So really they want g prime of 6. Okay, so let's see how we can get g prime of 6. So g prime of x is, and function g is a normal accumulation function. We don't have to adjust it all, so it's just f of x, which means g prime of 5 is f of 5, which I think on my graph is 4. Okay. Okay, let's, oh, but I said 6. Oh my gosh, hang on. Never mind, let me change that. 6. So g prime of 6 is f of 6, which is not there. I think it is there. So I think that's 6. Okay, you got to make sure you read the questions right, Miss Brady. Okay, so 2 is hard. You're like, oh, AROC, right? They wanted to get AROC, which is slope, but it's not slope of a 2 algebra function. It's the slope of g. So we need to find g of, I'm going 0 to 6, so g of 6 minus g of 0 over 6 minus 0. Okay, so let's get g of 6. G of 6 is from 3 to 6 of f of t dt. So let's look. Here we are at 3. We're going to go to 6. So we're going to use area. So this is 3 by 6. 3 times 6 is 18, so this is 9. Okay, now we're going to get g of 0, which is, and you're like, uh-oh, we're going backwards. 3 to 0 of f of t dt. Okay, so now we're going backwards. Okay, so be careful. Now I got this little triangle here. So that's 1 by 2. So this is an area of 1. And this has a radius of 2. So 2 squared pi. But we have to split it in quarters. So this has an area of pi. So this integral would be worse since we're going backwards. Minus 1 minus pi. Okay, so now let's get our AROC. So it's 9. Okay. Sorry, long day. Okay. It's 9 minus -1 minus pi over 6, which you could leave, but that's 10 plus pi over 6. That's the hardest one on the page, so good job. Okay, let's do 3. Okay, we need g concave up, so you need to tell the reader, just like you did in 1, g prime is f. G's concave up when f is increasing. So if I look at my graph, I think, and they just want me to go on 0 to 10. So I can start here, decreasing. It's only increasing in this little piece. So I think it's from 2 up to 6. Okay, let's do 4. Okay, so 4 says we need a critical point. Maybe that's what I meant. Okay, so we need G prime equals f, and we need f of x to be worth 0. And the only place that it's worth 0 is right here, and I think that's at 4. Oh no, it's 3. 1, 2, 3. At x equals 3. So that's the only critical point. And at x equals 3, f changes from, what's it change from? Negative to positive. So that means we have a local minimum. Okay, one more. Here we go. Oof. G of 0 is, we found that already. 3 to 0 of f of t dt. We found that was negative 1 minus pi. We did that in 1. Usually they may ask you that first. So if it was on a real AP question, they may ask you that first. Okay, then we want g prime of 5, which is equal to, we already told the reader g prime is f, so that's f of 5. And if I look at 5, the height on the graph at 5 is 4.